Yeah, let's hear about Jupyter Notebook and RMarkdown in modeling differential equations. Thank you.
All right, thank you. Thank you for coming, and appreciate the work the organizers put on for this conference. It's nice to have a virtual conference, and I'm excited to be participating. So I'll just share with you a little journey I've taken in developing materials for modeling purposes in my differential equations course. All right, let's see. So sometimes I think of exciting applications when I think of modeling, but teaching a separate modeling course here, I've learned and have come to enjoy modeling as a multi-stage process. So there's multiple steps to developing a model to tackle a real world problem. And that leads to a need for software like our Jupyter Notebook or RMarkdown to create integrated documents that I can engage with my students, and for them to do written papers they can turn in and things like that. So that's what I'll talk about today. Okay, so viewing Jupyter Notebook and RMarkdown as environments to create sort of a modeling report, that my students would write up and assemble all the products of them, all the pieces of a modeling project together. I was just looking for a way to do that. If it's a simple approach, Microsoft Word is fine. If you're there including Excel, graphs, then that's easy to incorporate in Word. But if I'm doing numerical work with a programming language like Octave or Python or R, then I need something else. And so my students will, I end up using RMarkdown more so, and I'll try to show you why. But they will create documents that integrate the various outputs that they get in their analysis while they work through a modeling project. And so these are the typical steps that my students might incorporate into their write-up. It can vary a little bit from course to course or project to project, but stuff along these lines. Okay, so similar to what Andy showed in the previous talk, there's Jupyter Notebook and RMarkdown are options that are similar to the Sage Math cell. They compile, Andy, you mentioned LaTeX, right? Your document, yeah, okay. So these do similar things. Let's see. What I like about RMarkdown is that I have more options for document styles and outputs. For example, these LaTeX Beamer slides that I'm using today were an output choice for me within RMarkdown. LaTeX editors can do way more with LaTeX, but you can't compile your programming code and have it create the outputs that I need. And so yeah, so Jupyter Notebook, RMarkdown is good for that. Jupyter Notebook comes bundled with an Anaconda distribution. All that's free. The numerical Python packages are included in that. And so this is something I get onto my hard drive and work off of that. As in the previous talk, Jupyter Notebooks consist of cells that accept markdown and code input, which you would then run each cell. So in this screenshot is, you can see a bit of a notebook interface here, and there's some cells that have been selected. The 3 hashtags in front of identify variables and parameters, that would be a markdown input for text formatting. If you do 2 hashtags, it'll be a large section header. 3 hashtags is not quite as big, so it's sort of a font size and bold. And so Markdown is its own language, kind of like LaTeX, but it's designed for text formatting. And then in a separate cell, below that, I would incorporate more Markdown, which is basically another word for text editing, which includes LaTeX commands and bulleting. And so the goal here is to create an environment that the students can write up their modeling work. And so that's part of what I'm showing here. And similarly, I can create notes and handouts for class. I can also share these notebooks with students if I want a template for them to start on a project and learn from. Once a student gets done with their notebook and they, or if they want to save it to a different machine, they can download. And as in various file formats, I tend to prefer an IPython notebook format when I download mine. The PDF to LaTeX feature, I don't use much. Seems like I needed to have my MikTeX working just right with my Jupyter notebook. And so sometime, I can't remember, I think I've had a little bit glitchy problems with that in the past. Here's, I'll pop out of the full screen presentation for a minute to share a sample student activity in, let's see if I can do this. Let me know if you can still see my screen. Can you see a Jupyter notebook now? Okay, good. So yeah, I could double click on these cells and you'll see the input coding, and each one of those would have to be run in order to display. You can include images using various commands that you Google to find out what to do. And so anyway, kind of like with the Sage Math cell, you create a document, which is really valuable, I think, for the modeling experience, because they're going to be putting together a lot of things for the projects, including LaTeX. And I have some TXZ output that I actually can't do in Jupyter Notebook, but I can in RMarkdown. So those create diagrams in LaTeX and so forth. I could keep scrolling just to kind of show what I find exciting about these notebook features for students authoring their work for a project. Python code for this particular project. In this particular project, I'll say more about a little bit later, but there's a volcano actually relatively young in the middle of Colorado, and some radiocarbon techniques were used to date the latest eruption. And so anyway, that's what we're looking at here. A lot of Python code to get some outputs and so forth. And so, yeah, I like them to walk through all these steps if possible with some of the bigger projects, including a discussion of results and references. Okay, when I go to, for students to turn things in, I'd like, my learning software on campus requires PDF submissions. And so when they go to convert their documents into a PDF, it's not as user-friendly, at least in my experience. I'll have them saved to, as a print to PDF kind of thing. And I don't get very nice, I mean, it works kind of, but it doesn't really look the best. You can get some bad page breaks. And I mean, it's not bad, but I find RMarkdown to be something that I like more. So what we're looking at now is a PDF. And so that's what I would see. I would upload it onto my iPad and write comments and so forth, but it's not my favorite output in PDF. All right, let me go back to my slides and go full screen again. I'm assuming, let me know if you can't see what I think you're seeing, but I should be back to full screen now with my slides. All right, so in comparison, our studio has an RMarkdown document style that can be used. Let's see, here I am. Okay, so RMarkdown, just like Anaconda or all this stuff is free. Our studio is free. Although I found out as of today, our studio is now known as Posit. I was checking some things last night. Our studio is still what it was, but today it's got a new name. It's expanding, and they seem to have some exciting visions in mind for what they'll do. But anyway, there's Python capability as well as R, Octave, Julia, and a lot of other languages. On my Anaconda distribution with Jupyter Notebook, I can only do Python. Online versions and CoCalc, you can get other languages, but for my desktop version, I just get Python. So I'm sort of glad that I can do other languages in RMarkdown. Here's some screenshots of what the sort of the R version of the notebook looks like. What you're looking at on the left side of this image is what you would see if you were to open a new document in RStudio. And you get a lot of document options, presentation styles, regular document presentation styles. And so sort of a suite of options, environments for creating materials. On the right is an RMarkdown screenshot, and it has all the same commands that I used for the Jupyter Notebook, except it doesn't have cells. And so your source code here is more like what I have in my LaTeX editor. I can put in 2 hashtags for a header in Markdown. I can put in $2 and do some LaTeX and get a display in math. And so rather than doing, basically I would copy and paste all these things into my Jupyter Notebook and get the same output. But what I like about RMarkdown is it doesn't have cells. Students, I think, might like cells initially because it provides a template and some structure. But when I'm authoring things, I prefer not to. I just like the flow of having what we see here on the right. You can still run individual chunks in the RMarkdown code. It's just like the cells. You can run, and you get a previewer for your LaTeX, which is kind of nice. All right, what else? When you want to sort of run your entire document, it's called knitting. And it'll compile, it sort of knits together all your language inputs for Markdown, LaTeX, and the programming language that you're working with. When I knit, when I'm creating materials, and I recommend this for my students, typically I'll knit to HTML first because it's faster and you get a good preview of what's going on. And then for final polishing and edits, I actually choose the Word output because students find that convenient. And I'll show you what that looks like, why it might be a good idea to knit to Word. Also, what you're looking at behind the language, what you're seeing behind in the screenshot is some TXZ packages that I've put into the header around lines, I don't know, 10, 11, if you can make it out in there. And for that, I actually have to knit to PDF. It'll give a good PDF previewer, and I can get my TXZ figures. And depending if my students have time for a project, they kind of have fun playing around with TXZ to create compartment diagrams and related things. So let me show you what the let me pop out of presentation mode and show you what my outputs look like if I go through Word first. And so this is what they would turn in, or what I would have for solution key for this modeling activity for modeling the radiocarbon dating for this volcano. I have more control over the images. I can resize them in Word. I can insert page breaks, and I get a better document. It looks nicer than the other one. Okay, what you're looking at now is my Jupyter Notebook. It just doesn't, it looks sort of still looks cellular, you know, it's broken up a little bit, and my images I can't replace, you know, because it's a PDF. Whereas if I go to Word first, I have a lot more control over what the final document looks like. And again, if you're a LaTeX fan, you can certainly do a lot of cool things in LaTeX itself, if only it would compile the programming code as well. And so this is all output from RMarkdown into Word. The blue section headers, that I could change, but that's the default when it gets sent over to Word. And so I feel like things look pretty nice, and my students I can create good notes and handouts for them, and my students turn in really nice documents too. So Word has that feature to it. All right, let me go back to my presentation. Let's make sure I click the right thing. All right, so those are some quick things about these different. Andy, you had a question about whether students edit their work in Jupyter, Markdown, or Word. They'll do a lot in their whatever they're starting with, like an RMarkdown. And then I just make sure at the very end, I'm sort of finicky about page breaks. I don't like programming code or commands on one page that gets broken onto the next page. So I usually have my own preferences that I have them sort of finalize in Word. But as much as they can do programming, they warm up to it and they seem to enjoy it. In the current slide, I'm showing you how I made my Beamer slides for this talk. I chose a Quarto document, which is something new, a Quarto presentation actually, which gives me, once I click on that on the left in the screenshot, over on the right side of the screenshot, you can see some of the options that it asks me about. And so I can choose PowerPoint, I can choose Beamer, and then create the slides that you see today. So I think I'm using a Copenhagen Beamer format with a default coloring. And so that's pretty nice. When it comes to student presentations on projects, they can do everything that I'm explaining here. They can take their homework assignment or their final project that they're working on, and they can create a presentation out of it by simply copying and pasting everything directly into a new document that's a presentation style. And I can't do that with Jupyter Notebook. At least I haven't seen how to do that easily. And so I like the ability to create materials the way I want my students to be interacting. So if they're going to present, say, on this volcano, if this was their project, a lot of times at the end of the semester, I'll have my students pick certain projects. They can be all different. So as a model of that, this would be what the presentations can start to look like. In case you're wondering, this volcano is about halfway, head west from Denver into the mountains, about 2 hours. If you keep going to Grand Junction, that's where I am. I'm in Western Colorado, way over here on the left side. Anyway, sort of some local stuff for my students. And so the rest of the slides are mostly just an example of what a presentation would look like. I showed you what a written paper might look like with all those 10 modeling components, assumptions, variables, analytical solution, numerical solution, and discussion of results. And this would be the similar scenario in a presentation. Some background information and a problem statement that's specific and measurable. That's something I work on with my students as part of the modeling, assumptions that are made. And if we happen to be doing compartment diagrams and word equations, they can include those. And so there's all this modeling structure that I think these notebook styles can really help students put together their work. And so that's sort of the main idea of what I'm trying to share here is for me, I have roughly 10 steps, 10 pieces I have them walk through: analytical solution, numerical solution. In this case, I'm using Runge-Kutta RK4, and I'm going to write my own code for it because I'm trying to be sort of instructive with them rather than, I could use the various DE tools, which are valuable in their own way. But for this particular assignment and some other ones, and the Euler method, same thing, I try to have them work through the code for that. All right. So by the way, the Cerro volcano erupted, well, less than 5,000 years ago. And it was basically magma was heating up water, and the steam from the water is what blew. And throughout Colorado, we have various places that have hot springs. So I would imagine that the geology there is related. All right. That brings me to the end of the talk. The references for the material in here are shown, including that initial image at the beginning of the talk. So thank you for your attention. And if you have any questions, let me know.
Thank you. Anyone got questions? Feel free to unmute yourself.
I just have a quick follow-up comment. I'm definitely going to look into Posit now because I have been writing my class notes just for me in Markdown, and actually the web page with the links that I shared in my presentation that I gave the URL to, I wrote that in Markdown and exported it to HTML. Markdown is an incredibly useful language for writing structured documents without a lot of syntax and like LaTeX notation built in. So if you don't know about Markdown, you really should learn. It's really made my personal workflow a lot easier, and I can see how with RMarkdown it would be even better. So I just want to put another plug in. It's a very useful productivity tool.
Yeah, Ping, you asked about the referencing. So far, that's one thing that has been lacking. But when I looked at Quarto's documentations just this today and yesterday and the day before, there is information on citations and BibTeX and incorporating that. And so that I've sort of missed, that I haven't been able to do that in my Markdown. But it looks like you might be able to going forward. Okay,
that's really good to know. And I really like what you said, that, I mean, one of the frustrations I had with my students is whatever they typed out in Word, when they prepare presentation, it's like a lot of extra work. It's not a simple copy paste. But with this, it's clearly like much easier. They don't have to do pure, extra labor just to move things around. I really like this. I'm gonna look into it.
Yeah, and like Andy's saying, if you haven't picked up on Markdown, it's so easy to learn. It's easier than LaTeX by a long shot, but it gives you these options for HTML pages with links, and so as a math teacher, it's really opened up a new world for me, especially once I hit courses recently where I'm teaching where there's numerical methods that are required. Before that, I was using Overleaf a lot, or Microsoft Word and Excel and things like that. But programming is what kicked me over the edge. Is I need something, presentations, papers, everything. I need something that can put it all together.
Yep.
Also, I think these Markdown and Cell environments, they might be easier for students to learn LaTeX at first because they just focus on the here and now commands rather than lengthy preambles and document styles and things like that. I mean, certainly our math majors and physics majors do amazing things with LaTeX. They learn and they like it. But at first glance, these Cell and Markdown environments offer sort of an easy intro.
Thank you. Do we have other questions? If not, like I mentioned earlier, we know how to email. Okay, that's always the best way to reach out. And let's thank our speaker again. And